Quick, quick intro. Actually, it's great to be here in Chicago. I'm Craig Hill. I'm a distinguished SE out of the Herndon, Virginia. I'm with Cisco. I work in public sector CTO office and been a network engineer all my life, of course. Working with Cisco about 23 years now. But have been kind of shifting towards some of this software automation programmability that I'd really like to, I think is a really, really great topic to talk about today. So. Actually, in the session or the copy that you guys will get, you'll get my email address as well. So if you want to, email me after with any questions, feel free. So a little bit of context around this topic, and I have a full 30 minutes, so I want to get rolling here. But I think this community, as much as any that I work with, I think you guys have already moved past, hey, look, why network automation? Why do we need it? I think there's some areas that can't survive without it, some of the hyperscale providers, et cetera, and some of you folks as well. But the idea today and what I'd really like to cover is, anybody in here done any work with Yang, the Yang models? Okay, so there's a few of you, and I wish I could do a little bit more of a tutorial just on Yang, but there's a lot of good pieces out there. So any of you who have worked with Yang know the power of model-driven, and you'll understand after this session, hey, what is the power of model-driven? What do we mean? Specifically around network automation and network elements. The one thing of you that the folks that know the power of what Yang brings and what a model brings to the table, any of you who work with Yang know that it's not the most intuitive interface right now, and actually how we leverage APIs to the Yang model or how we can manipulate different structures through the Yang model. And what I'd really like to do today, there's an SDK, it's an open source SDK. We've been working on it a lot at Cisco, but it's open for anyone, is to describe how we can go about simplifying this for network operators, as well as what's really cool is introducing more ways that we can get the application developer to be able to program and automate the network elements as well. And that's really the kind of the gist of what we're gonna cover today. So very quickly on the outline, I'm gonna level set real quick. Where does this toolkit sit as it relates to the world of automation and the different buckets of automation? And then we'll shift into this model-driven programmability. And the idea is, well, whether the intro to model-driven programmability, and then I'll talk about this SDK, which is YDK or Yang Development Kit, and really how that really simplifies things for those of you looking to get or move towards this model-driven type capability. And I have a demo, a very short demo. The demo, I'll actually post it up on GitHub. I'm just going to run one of these YDK apps I'll show you, and we'll get into that. It just kind of ties all the PowerPoint together for you. It's very, very quick, but it'll give you an idea on really what we're talking about here. And then the summary, and then of course, and there's some really great YDK sources that you guys can pull down. All the apps that I talk about today and the bindings I talk about today for this are already up on GitHub. So we post all of this up on GitHub so you have access to that as well. All right, so look, choices are a good thing, and this is a very quick level set, but I had this conversation with a lot of customers, and the idea here is, and I call it this little three-pillar type format architecture when you talk about customers looking to leverage automation programmability. And you can really narrow this down, at least I do. I try to narrow it down to three pillars. And the idea here is the pillar on the left is typically a more of a prescriptive type of automation or SDN type solution design from vendors, whether it be Cisco or Juniper or Arista, et cetera. Those solutions are typically tied pretty closely to the hardware. And so there's a little bit of a tightness with the vendor itself. They typically come with a GUI, et cetera. Then when you go to this more do-it-yourself, that really targets those customers that have a little bit more of experience with automation programmability. For example, in the middle, they could say, hey, Craig or Juniper or Cisco, I like your hardware, I like your silicon, but I don't want your controller. I actually do my own automation. I have my own automation tool set. I might fit there. And then the one on the right is more along the lines of those customers that fully embrace automation, right, or multi-vendor. So I'm going to do a multi-vendor environment, and I want to leverage that. So, and here's some of the toolkits that are out there, and not all. These are some of the examples of these prescriptive solutions over here on the left here. But to do it yourself, I don't know, those of you probably familiar with Python. There's some sessions today. Ansible is an area that I've actually been dabbling in as well. But the one I really want to focus on today is these. And this is where it fits. And what's really nice about this and why I'm straddling both, open as well as multi-vendor is we have the ability to do both with this. And I'll show you how through the openness of Yang models, and we'll talk a little bit more there. But this is where it's fitting. So if you sit in and you start talking about, well, what is model-driven? Let's just start with what is a model. We're going to be talking about data models today, but when I talk about data models, just think about a model in general. It's a very prescriptive representation of something. And I have a colleague that does a really great job. He talks about these models, and the way he likes to refer to it as, like the context of a driver's license, for example. You typically have, your name, and then of course you have your, hair color, eye color, your sex. Are you you're an organ donor or something like that, like we have in Virginia. So think about that. Each of those parameters, that is a model of how somebody is being described. But in addition, that model actually, some of those parameters are integers, some of those parameters are strings, right? And that really kind of dovetails me back to this is when you look at data models, the data model is nothing more than a representation of something in that. Let's stick with the router. So think of it as an interface. An interface, I typically have a name, I have a description, I have an MTU, I have an IP address, et cetera. And then we're clearly defining that model or that representation in that network element. Typically in this scenario, the beauty of the models is a tree structure. So it's very structured. So if you're going to parse data from it's ideal for machines. The other thing is it's typically decoupled from the hardware, which is really awesome, right? So it doesn't care about the hardware. It cares about the representation of the capability of that box. And then there's some type of a network management protocol associated with it as well, and we'll get a little bit more into that. If you think about data models in general, there's three main models out there right now. So those of you who are kind of embrace the open source, this is really, really a nice fit. So this is based on RFC 6020, which was really the original, IETF draft there, and from an IETF perspective for those models. But the idea is you really have three, and the native models are typically tied to a hardware or to a vendor, right? So there's going to be much more in-depth, modeling capabilities of that particular hardware and that vendor. But then you have these on the right, these open models, and there's really two today. The IETF, of course, and then OpenConfig, which was really driven out of like a Google consortium, and it's really gaining steam. So it gives you that level of abstraction that is absolutely multi-vendor in those type of scenarios. Now, there's not as many, there's not as many details or as many models of representation in OpenConfig and IETF as native. But again, you probably are going to mix and match. I had one customer tell me, well, two customers tell me on two different sides of the spectrum. The one was, I'm going to actually, use open when I can and native when I must. And then the other guy is, hey, well, I'm going to use native when I can and, open when I must, right? So, it just depends, but you have that capability. So this is one of those slides that would be ideal if you could kind of take it away when you start talking model-driven. And this is really moving, past the CLI, past SNMP, past syslog. So if you take a look at this stack, and I'll work from the bottom, you have your network devices. The second layer there are the Yang models, which are shipped with these devices, right? It's a representation of those devices, of the capabilities of those devices. But take a look at this protocol encoding and transport. The idea of this model-driven is that we decouple those layers from the Yang model itself. So the idea here is that, look, we know that netconf and XML are tied together, but if I wanted to use gRPC, for example, I might want to use JSON or I might want to use Google protocol buffs. But in those type of scenarios, I don't want them to be tied to the model. If I change the model or I use OpenConfig models or I use native models, I still might have certain applications that I want to use certain transports and encoding for. So the decoupling of that is very, very important. If you look at the far right, another very important thing when we talk about just automation in general is typically southbound to the device. I'm configuring the device. But the beauty of leveraging these models as well is I have the ability to actually stream data in the model format up southbound to applications, or I could throw it up to a message bus to be parsed further, like Kafka or Pipeline or something along those lines, right? So I have the ability to do this, what we call closed loop, where I'm configuring down and then I'm taking telemetry out of the router based on the model. The model is dictating what data I'm actually pushing. And that is another very, very important element of this programmability stack. So just to summarize before I get into, hey, what is YDK? Look, these models, very highly structured, computer-friendly, right? So I can tie my tool sets and my tool chains into this. The idea that I have multiple models that are native, that are typically tied to the vendor. I have a set of open models as well. And of course, they're decoupled from the encoding and the protocol and the transport like we talked about as well, right? And again, what we'll talk about here, which is one of the big takeaways, and we'll dive deeper into this, is that from a model perspective, and like, for example, when we ship our devices, the models generate their own documentation. So those of you not familiar with it, how cool is that? It's like, well, I said when I was really, just learning this and pretty stupid on the topic, it's like, hey, who generates the documents for these APIs that I'm going to show you? The model actually generates the documentation for these models, right? So we'll talk about that. And again, wide standard support from an open source perspective, which is really the direction we really want to go. So what is YDK? What is this Yang development kit? So it's an open source toolkit. Before I dive into that, there's very important area here that we're starting to catch a transition, and I see a couple guys I had lunch with, and we were talking about this at lunch. We have our network engineer here on the left, and he's very proficient in network protocols and network management. We all understand OSPF, ISDIS, BGP, MPLS, et cetera. But most of us, at least starting, have very minimal programming skill sets. Look at the software developer on the right, very proficient in software development. If I give him APIs with API documents, he can pretty much go to town on what we want to do. But what you're starting to see is these lines blurring. And actually, some of the hyperscale providers, and maybe even some of you guys sitting here today, in your operations center, this might be one individual, right? So the idea, though, is that until we get there, one of the big goals for YDK is to meet this, avoid the complexities of these Yang models. So, you don't have to actually have a deep dive, abstract view of what the Yang model offers, what the details of it are, what the tree structures are, what is a leaf list, what is a container, all that lingo as it relates to the Yang model, you don't need to know. And then from the application developer perspective, if I'm able to take that Yang model and produce APIs for him to actually develop towards, I've killed two birds with one stone. And that's really the goal here with this, is that we're trying to simplify the complexities of what the Yang model brings, as well as simplify the interface so I can leverage these Yang models in languages that you're typically used to when you code them. So this looks familiar, right? But there's one additional layer in here in this protocol stack that I was showing you earlier. And this programming stack here is that API layer. So that's where YDK sits. And I'll show you the details of this in a minute. So we still have our Yang models, but from those Yang models, we are actually then producing these APIs. And you can see with that, those APIs and that API layer sitting right there, the application sitting above it, you can start to see how we can simplify some of the capabilities and the complexities of those of you that have continually fought and battled with trying to get your arms around how to use these Yang models in a very, very efficient way. Okay, so what is YDK? So in short, it offers a model-driven API, and the idea is that we're simplifying app development, but again, the APIs are generated directly from the Yang model. So what does that mean? What that means is multiple things, but if I'm running this locally in my application, I'm running YDK locally in my application, I can do very, very rich validation checks because I'm doing the validation checks against APIs that were created directly from the Yang model, right? That's very, very important, and it gives me these capabilities then to do a lot of cool things that we can't do today, or some of the tool sets we have today can't do. So the idea is that I can do these checks, and I'll show you in my demo, prior to actually poking the device. And not only, when I say rich validation, not only am I checking against those parameters, the other thing that I can do is I can check specifics of those fields. So for example, in my demo, I'll show you, I'll do a little error where I try to fake the model out and let it do local validation so it knows exactly what those parameters are. It knows that an MTU has an integer. It knows that that integer in an MTU has a range, right? It knows that a description is a string. So those type of things we can actually do. And if you also look, and I think I'll dive into it here a little deeper, it's multiple languages. So today, we actually have 3 different languages now out of this SDK that we can provide these APIs for, these API bindings. And today it's Python, C++, and Golang. So you have whatever flavor you like there as well, you have those capabilities. So this is how this all comes about from a YDK perspective and really the guts of this. Now if you look at, well, what is the structure of the API? There's 3 things here. And I'll start with the easiest ones first. So how do we do this? We basically have some software, it's called YDK Gen. And YDK Gen takes the model and then it spits out these bindings, right? Something that the top and the models you don't have to worry about. It's done for you. Same thing on the bottom, we basically simplify how you deal with these transport protocols, specifically netconf, which is all which all the YDK supports today. We've been looking at gRPC as well, and there's certainly RESTconf has some interest. The services is where the developer really gets involved. And the idea of the services, and I wish I had more time, but my links that I give you for reference, you can dig real deep into, hey, what are my options? This CRUD option, which is what I'm going to actually demonstrate, is the create, read, update, and delete. And the idea there is that's how I'm making my modifications, right? But you have others, that you can do here. The netconf, if you're really into netconf and the netconf construct and context, you have the ability to leverage this toolkit with that. You can do the codec, just basically does a translation to XML and JSON, so you have the ability to translate the model there. An executor, et cetera, gives you like, well, yeah, I want to execute like ping commands or something like that. So you have some capabilities, but these are the real 3 main structures of the operations, and this all comes as a packaged, kit for you, a software development kit for you. This I already referred to, so you have the 3 different model types, IETF, OpenConfig, and native. And again, they're the 3 languages that we support today. We just started supporting Go like in early February, so it's relatively new. But even if you go to ydk.io, I don't think that the Go documentation is there yet, but it is in GitHub. And then just final, before we get to the demo, this is just my, hey, hear it a couple times, right? The idea of us doing the validation and being able to do the validation in the app, right, before we actually hit the box. So if there's an error, and I'm trying to change, configurations and plow through 100 routers, the idea that I don't have to unnecessarily go to those routers and then figure out that I didn't, that the context of what I was trying to do in my program was wrong. So I'll show you that as well. And, we do a lot of different variations and checks as well. It's all done for you, and I'm really going lightly over this because, man, there's a lot of work that's done for you. And I think one of the things I talk about with some of the guys, that really do YDK more than me is you really have to understand the work that they've done and put into this. If you need to understand working with Yang models prior to this is my point. It's a little painful. So this is really allowing us now to take advantage of, what that whole model-driven or that model construct brings to the table and the structured data it gives us. So what I'd like to do here very quickly, and that we all know the demo gods here, so I try to limit the chance of being bit by it. But I'm doing this locally, so I have YDK running, and I'm using. You can also get YDK in a Vagrant box, which I actually really like. So I don't have to deal with updating it, et cetera, in the version of Linux I'm running. So that's how I'm doing it. And then I have a cloud services router just running in a VM here, so we'll run it local. And what I'm going to do here is a typical interface configuration. I'm just going to do the interface name. I call it loopback99. I think I have the data here instead of just talking about. Let me show you. So what I'm going to do is I took the, those of you who have played with Yang a little bit, you're probably familiar with pyang, and I use pyang ftree, which gives you a hierarchical tree structure of the model itself. It's a really nice translator if you're not familiar with the pylang utility. And if you notice this, on the left, this definition is, this is just basic Python. And what I'm going to do is I'm using Python aligned with the API documentation. So I did this app, actually. And what I'm basically doing in this scenario is just adding the name, the description, IP address mask, and then I'm adding a VRF name to it called VRF1. And I'll run this, and I'll show you. And then, and of course, the output here is, in the CLI. So let's take a look here and see if it works. You guys know how this goes. Exactly. I'm confident, buddy. So on this router here, if I just do a show IP interface brief, I do not have the loopback 99 in there, so you can see that's clean. So what I'm going to do is, and I'll bounce back, I can show you a little bit about what the code looks like. Actually, here in this definition, where is that? What I was going to do with that address is, so it's the address here is 10.99.99.99, and what I want to do is show you a local validation first. What I'm going to do is just change this to like F. So obviously, an IP address of 10.99.99.99F is not a good thing here, right? So let's test it. So I really like, probably one of my favorite things here is the actual local validation. So one of the things that you can do here, now keep in mind what I'm doing here, this is just a sample app. Right, so there's over 700 sample apps that this team's created. So these are just nice little snippets of different, Yang models that are actually, or YDK apps that, are just the most popular. And I've contributed to a few, but you can take the snippets though, and then you can use them in your real code. Even if I'll talk about it in a minute, even how you can maybe tie it into Ansible. But again, and I'm running this in verbose mode so we can actually see it. So what this will do is, this is going to run and check locally, and it'll actually, first thing it'll do is actually do a capabilities exchange to the router, say, hey, what Yang models do I have available? And so the box will respond back, these are the Yang models I have, and then it'll actually do a local check. And of course, I misconfigured that configuration here, so it's going to go through this, and then what it should do is fail like it did. And one of the things I really like in the most recent code here is we've gotten a lot more descriptive on exactly what's going on here. So it says data is invalid here at this line here. It says data is invalid, error details value does not satisfy the constraint. So it spits back, and it never even poked the router at all. So if it doesn't validate locally, then it won't connect via its netconf connection down to the box. So if I go back and let's just change this guy back to what it should be. Then let's just give you a little bit of a working config here on what it's actually going to be doing. So I run the same thing from a verbose perspective. It'll go do a capabilities exchange again, and then it'll show you in the Yang model in an XML format, of course, because we're using netconf, right, for this, exactly what it did, and then that the operation succeeded. So in here, if I step down here, so it did this capabilities exchange up top. It's a lot of data, but you can see up here, path where the models are. It shows you the IP address, port 830, which is netconf. That timeout of -1 is infinity, but you could set that if you wanted. And then you can see the different parameters that I actually put in here as it applies to the model. And then, of course, it basically, then it closes out its connection from a netconf perspective down in here, and then disconnects. So then when you go over to the router here, we just basically say, hey, let's go take a look at, was 99 there? And the answer is, show run interface. It basically configured the interface on the, on the router. So again, all through using the Yang model, YDK local checks, right? And then, configuring the device. So there's a lot of different things that we can do in this as well. So because this is Python now, some of you may be more familiar with C++ and Go. We have that. But the other thing that we can do is it's starting to get a little more popular, and I actually had a colleague do this last year at our Cisco Live event, is because Ansible, some folks were really liking Ansible, and they're really getting comfortable with writing their own custom Ansible modules, which leverages Python. So what you can do is you can leverage Ansible and all the goodness of Ansible, like you maybe like it or prefer it. You might like the templates, you might like the Jinja 2 elements of it, so you can execute the playbook. But anytime you go to the device, for example, you actually then can call up this piece of YDK, and anytime you poke the device, you can use the Yang models in the YDK app because it just blends really, really nicely because it's Python code, right? That's the whole beauty of it. You're not going to take these samples and start operating your network with this sample. The idea is that you're going to incorporate these samples in this code, and this Python code, or C++, or whatever you're using, and incorporate it into your main operations infrastructure. So those of you who are saying, well, I'm using Python, and I'm using the netconf client, and I have to use XML if I want to use, I have to do some XML format or call an XML file, you can see how simple we're making it for you here by leveraging these API bindings. This is really, really powerful. And I don't know if you saw, but on the, I'm actually wasn't done with this totally, and so I did the VRF I already configured, but this GitHub repo, I'll have this up for you. So if you get YDK loaded or you want to run it out of Vagrant Box, you can just put in your parameters of the IP address to the router and test this right away. There's a little hello world on the README file of the GitHub too, that if you want to just quickly test it, you can do that as well. So I'll make sure that this is updated on the site for us. So just to summarize, and then there's a lot of resources that I put in here specifically for you. I'm sure you guys have a lot of questions, so I'm going to be here, and I think we're up against a break, so maybe we can open up the questions in a minute. But just to just for your key takeaways, think about that visual of that application stack that I put up there, and how the power of the model it's very, very powerful in the sense of, again, it's structured format of an element in the router itself. And I will say in iOS XR, and I'm sure some of the other vendors are doing this as well, no new features are being shipped out, without a Yang model representation. And if there is something that we find that does not have a Yang model associated with it, it's registered as a software defect. So that's how we are absolutely moving forward in the schema that we have in iOS XR, and hopefully with iOS XE and XOS we follow. Some of the other vendors have the same capabilities, right? So again, this model-driven approach, the idea of what we're doing with models, but what YDK can do to simplify things here. The cool thing is it's open source. We're very committed to this. We've worked with Google on some of the open config, and we're very much endorsing the open config capabilities as well. Again, these APIs being generated directly from the model, you just have other things that you can do and execute locally before you go and poke the device with this rich data validation. Now, the multi-language, we're at those 3 right now. But, I've heard rumblings of others. I've heard rumblings of Ruby. I've heard rumblings of Java. And it's really customer-driven. And because it's open source, there's no reason why, we couldn't get contributions on that as well. So keep that in mind as well. You can go through these different references if you're really interested in this, how you get it. What I would highly recommend is on this, a close colleague of mine that I've learned a lot from, Santiago Alvarez. He's a distinguished engineer leading the effort on this outward-facing for us. He's done some really nice presentations. He did the basic one, kind of what I did, in about an hour and a half, so he gets into the details of Yang at Nanog 68, and it's a YouTube video. And then he just recently did a nice one as well, which is a little bit more of that closed loop that I was talking about with streaming telemetry at Nanog 71. The one at Nanog 71 as well uses all open config models. It doesn't use the Cisco native models. It uses all open config models. So some really nice sessions out there and that you can check out. And if you're interested in learning more, and again, I think we all know the best way to really figure out if this is real or not is to download it and give it a try. But those of you who are proficient in Python, this is going to be really, really easy for you, especially if you're proficient in Python and a network engineer, right? Because you know the hierarchy and the structures of, for example, like I gave you, what an interface looks like, or what BGP looks like, or what OSPF looks like, or how to configure your automated VRF. I'll leave you one last one. All my stuff has been very use case driven. I work in the U.S. federal space, so exchanging pre-shared keys. I wrote the apps for that in iOS XR as well as iOS XE, just to automate that process and use the Yang model to do it. But again, all of that has been very use case driven. So with that, I went over 5 minutes. Again, great to be here. I'll be around here for the rest of the day if you have questions, and I'll make sure my email is in the handout as well. So thank you very much.